Welcome to our video on the remarkable Indian Space Research Organization, also known as ISRO. Today, we embark on a journey to unveil some fascinating facts about ISRO and its extraordinary contributions to space exploration and technological advancements. Let's begin by paying tribute to the visionary, Dr. Vikram Sarabhai, the founding father of ISRO. Driven by his conviction, he envisioned the importance of space activities for a developing nation like India. His belief became the cornerstone of ISRO's unwavering commitment to scientific progress. Dr. Vikram Sarabhai is considered as the father of the Indian space program. He was a great institution builder and established or helped to establish a large number of institutions in diverse fields. He was also chairman of the Atomic Energy Commission. He, along with other Ahmedabad-based industrialists, played a major role in the creation of the Indian Institute of Management, Ahmedabad. Some of the most well-known institutions established by Dr. Vikram Sarabhai are Physical Research Laboratory, PRL, Ahmedabad; Indian Institute of Management, IIM, Ahmedabad; Vikram Sarabhai Community Science Center, Vasisk, Ahmedabad; Darpana Academy of Performing Arts, Ahmedabad, along with his wife Mrs. Mrinalini Sarabhai; Vikram Sarabhai Space Center, VSSC, Thiruvananthapuram; Space Applications Center, SAC, Ahmedabad. This institution came into existence after merging 6 institutions centers established by Vikram Sarabhai. Faster Breeder Test Reactor, FBTR, Kalpakkam; Variable Energy Cyclotron Center, VCC, Kolkata; Electronics Corporation of India Limited, ECIL, Hyderabad; Uranium Corporation of India Limited, USIL, Jadugoda, Bihar. Interesting facts about ISRO. Space research in India. Modern space research in India can be traced to the 1920, when scientist S.K. Mitra conducted a series of experiments sounding of the ionosphere through ground-based radio in Kolkata. Later, Indian scientists like C.V. Raman and Meghnad Saha contributed to scientific principles applicable in space sciences. After 1945, important developments were made in coordinated space research in India by 2 scientists, Vikram Sarabhai, founder of the Indian Space Program who established the Physical Research Laboratory at Ahmedabad, and Homi Bhabha, father of the Indian Nuclear Program who established the Tata Institute of Fundamental Research in 1945. In 1950, the Department of Atomic Energy, DAE, was founded with Homi Bhabha as its secretary. It provided funding for space research throughout India. In 1954, the Aryabhatta Research Institute of Observational Sciences, ARIES, was established in the foothills of the Himalayas. The Rangapur Observatory was set up in 1957 at Osmania University, Hyderabad. Space research was further encouraged by the Government of India. Formation of INCOSPAR. The Indian National Committee for Space Research, INCOSPAR, was set up in 1962 by Prime Minister Jawaharlal Nehru on the urging of Vikram Sarabhai. There was no dedicated ministry for the space program initially, and all activities of INCOSPAR relating to space technology continued to function within DA. INCOSPAR was superseded by ISRO. Under the government of Indira Gandhi, ISRO was formed on 15 August 1969 and superseded INCOSPAR with an expanded role to harness space technology. Department of Space, DOS, was set up and ISRO was brought under DOS in 1972, institutionalizing space research in India and forging the Indian space program into its existing form. What is ISRO? Indian Space Research Organization, ISRO, is the National Space Agency of India. The organization is involved in science, engineering and technology to harvest the benefits of outer space for India and the mankind. It operates under the Department of Space, DOS, which is directly overseen by the Prime Minister of India. Legends who shaped India's space program and ISRO. Although India's space program owes its birth to the vision of Vikram Sarabhai, it was Dr. Satish Dhawan and Dr. APJ Abdul Kalam who lent substance to this vision and built ISRO into the world-class body that it is today. India's first rocket launch. The launch of the first sounding rocket from Thumba Equatorial Rocket Launching Station near Thumba, Thiruvananthapuram, Kerala, India on 21 November 1963 marked the beginning of the Indian space program. This launch was conducted under INCOSPAR. India's first satellite, Aryabhatta. Aryabhatta was India's first satellite, named after the famous Indian astronomer. It was launched on 19 April 1975 using a Cosmos 3M launch vehicle. It was built by ISRO and launched by the Soviet Union as a part of the Soviet Interkosmos program, which provided access to space for friendly states. India's first indigenous communication satellite, Apple. The Ariane Passenger Payload Experiment, APPEL, was ISRO's first indigenous, experimental communication satellite. It was launched into GTO, Geosynchronous Transfer Orbit, by the third development flight of ESA's Ariane vehicle from Korea on 19 June 1981. ISRO's contribution to rural developments. Beyond space exploration, ISRO has been instrumental in enhancing satellite communication and rural development. Through initiatives like the Village Resource Centers, VRCs, Teleeducation, Telehealthcare, Land and Water Resources Management and Telefishery, ISRO has bridged the digital divide and brought progress to remote areas of the country. Various programs are carried out by ISRO addressing the developmental priorities of the country for planning, monitoring and impact assessment with monitoring of Integrated Watershed Management Program (IWMP), space-based information support for decentralized planning (SISDP), and GIS implementation of MGNREGA (JOMGNREGA). ISRO has hosted more than 9.7 lakh activities and 600 impact evaluation report. ISRO's range of satellites. In order to fulfill vision and service goals of India, the Department of Space and ISRO has been developing technologically advanced satellites for communication, Earth observation, scientific, navigation, experimental, small, meteorological and student satellite. ISRO's range of launchers. Launchers or launch vehicles are used to carry spacecraft to space. India has 3 active operational launch vehicles: Polar Satellite Launch Vehicle (PSLV), Geosynchronous Satellite Launch Vehicle (GSLV), and Launch Vehicle Mark III (LVM-3). India has 3 under development launch vehicles: Human Rated Launch Vehicle (HRLV), Small Satellite Launch Vehicle (SSLV), and Reusable Launch Vehicle Technology Demonstrator (RLVTD). Polar Satellite Launch Vehicle (PSLV). Polar Satellite Launch Vehicle (PSLV) is configured with 4 variants like 6, 4 to solid rocket strap-on motors and core-alone versions. Variants will be chosen based on the payload weights and orbit to be accomplished. PSLV has been a versatile launch vehicle deployed for launching all the 3 types of payloads with Earth observation, geostationary and navigation. It has got highest success rate and considered as workhorse of ISRO. Geosynchronous Satellite Launch Vehicle (GSLV). Geosynchronous Satellite Launch Vehicle (GSLV) with indigenous cryogenic upper stage has enabled the launching up to 2-ton class of communication satellites. The United States had blocked India from obtaining cryogenic technology from Russia, leading India to develop its own cryogenic engines. Launch Vehicle Mark III (LVM-3). Launch Vehicle Mark III (LVM-3), previously known as GSLV Mk3, is the next generation launch vehicle capable of launching 4-ton class of communication satellites and 10-ton class of payloads to low Earth orbits, LEOs. The vehicle was developed with completely indigenized technologies including the C-25 cryo stage. The launch vehicle has a track record of all successful launches even from the first development flight. The human-rated LVM-3 is identified as the launch vehicle for Gaganyaan mission, which is named as HRLV. Small Satellite Launch Vehicle (SSLV). Small Satellite Launch Vehicle (SSLV) is being developed with complete indigenous technologies to meet the small satellite launch market on demand-driven basis. Reusable Launch Vehicle Technology Demonstrator (RLVTD). Reusable Launch Vehicle Technology Demonstrator (RLVTD) is one of the most technologically challenging endeavors of ISRO towards developing essential technologies for a fully reusable launch vehicle to enable low-cost access to space. In order to achieve high accuracy in placing satellites into their orbits, a combination of accuracy, efficiency, power and immaculate planning are required. ISRO's launch vehicle program spans numerous centers like Vikram Sarabhai Space Center, VSSC, located in Thiruvananthapuram, is responsible for the design and development of launch vehicles. Liquid Propulsion Systems Center, LPSC, and ISRO Propulsion Complex, IPRC, located at Valiamala and Mahendragiri respectively, develop the liquid and cryogenic stages for these launch vehicles. Satish Dhawan Space Center, SDSC, located at Sriharikota, is the spaceport of India and is responsible for integration of launcher. ISRO's range of spaceports. ISRO has 1 active spaceport, i.e. Satish Dhawan Space Center, SDSC, and 1 upcoming spaceport, i.e. Kulsekharpatnam Spaceport. Satish Dhawan Space Center, SDSC. Satish Dhawan Space Center, SDSC, formerly Sriharikota Range, SHR, is the primary spaceport of the ISRO, located in Sriharikota, 80 km, 50 mi, north of Chennai, Tamil Nadu. Sriharikota Island was chosen in 1969 for a satellite launching station. The center became operational in 1971 when an RH-125 sounding rocket was launched. The center currently has 2 functioning assembly buildings and 2 functioning launch pads used for launching rockets. The first launch pad began operation in 1993 and the second launch pad began operation in 2005. A third launch pad was proposed in 2012, which is still under review. Originally called Sriharikota Range, SHR, the center was renamed in 2002 as a tribute to ISRO's former chairman Dr. Satish Dhawan. Kulsekharpatnam Spaceport. Kulsekharpatnam Spaceport is an under-development spaceport in India. It is being built as ISRO's second spaceport. The spaceport is located at Kulsekharpatnam in the Indian state of Tamil Nadu. This port will mainly be used by ISRO for launching small payload. Geopolitical pressure on ISRO's growth. The United States had blocked India from obtaining cryogenic technology from Russia. ISRO was under US government sanctions between 6 May 1992 to 6 May 1994. Recently, the Central Bureau of Investigation, CBI, the premier investigative agency of India, submitted before the Kerala High Court that the 1994 espionage case involving former ISRO scientist Chandrayaan and others was part of a conspiracy hatched, possibly with involvement of a foreign hand, to derail the development of the cryogenic engine technology by India. The United States had also refused to help India with Global Positioning System (GPS) technology during the Kargil War in 1999. In 2003, Prime Minister Atal Bihari Vajpayee urged scientists to develop our own cryogenic technology, navigational systems, advanced technologies to land humans on the moon and programs for lunar, planetary and crewed missions. This was a clear message from the Prime Minister Atal Bihari Vajpayee to the scientist community to be self-reliant with the technologies required for our country's growth and security. ISRO started developing indigenous technologies like Indian Cryogenic Engine, IRNS Navigation Satellite Program and Chandrayaan-1 as the first step towards the moon for the country. First Indian Cryogenic Engine, C-20. The C-20 is a cryogenic rocket engine developed by the Liquid Propulsion Systems Center, LPSC, a subsidiary of the ISRO. It has been developed to power the upper stage of the LVM-3. It is the first Indian cryogenic engine to feature a gas generator cycle. The high-thrust cryogenic engine is the most powerful upper-stage cryogenic engine in operational service. Indian Regional Navigation Satellite System, IRNS. The Indian Regional Navigation Satellite System, IRNS, with an operational name of NAVIC, this indigenous navigation system developed by ISRO provides accurate positioning and timing services for various sectors, including transportation, disaster management, and more. It covers India and a region extending 1,500 kilometers, 930 mi, around it, with plans for further extension. NAVIC will provide two levels of service, the standard positioning service, which will be open for civilian use, and a restricted service and encrypted one for authorized users, including the military. Chandrayaan-1. Chandrayaan-1 was the first Indian lunar probe under the Chandrayaan program. It was launched by the ISRO using PSLV rocket in October 2008 and operated until August 2009. The mission included a lunar orbiter and an impactor. The mission was a major boost to India's space program, as India researched and developed indigenous technology to explore the moon. The vehicle was inserted into lunar orbit on 8 November 2008. On 14 November 2008, the Moon Impact Probe separated from the Chandrayaan orbiter and struck the South Pole in a controlled manner. During its 25-minute descent, Chandra's altitudinal composition explorer, CHASE, recorded evidence of water in 650 mass spectra readings gathered during this time. Mangalyaan. Prime Minister Manmohan Singh approved the project on 3 August 2012 after ISRO completed 125 crore rupees, $16 million of required studies for the orbiter. The Mars Orbiter Mission, MOM, also known as Mangalyaan, was a space probe orbiting Mars since 24 September 2014. It was launched on 5 November 2013 by the ISRO using PSLV rocket. It was India's first interplanetary mission, and it made ISRO the fourth space agency to achieve Mars orbit, after Roscosmos, NASA, and the European Space Agency. It made India the first Asian nation to reach the Martian orbit, and the first nation in the world to do so on its first attempt. The total cost of the mission was approximately 450 crore rupees, $73 million, making it the least expensive Mars mission to date. Mangalyaan became ISRO's most celebrated achievement. First images of Mars captured by ISRO's Mars Orbiter mission, MOM, also known as Mangalyaan. 104 satellites in a single launch. On 15 February 2017, ISRO's PSLV successfully launched the 714 kg Cartosat 2 series satellite along with 103 co-passenger satellites, with a total weight of all the 104 satellites carried on board was 1,378 kg. It created a world record of launching maximum satellites in a single launch, which was recently changed as SpaceX successfully launched 143 satellites in single launch in January 2021. Future directions to ISRO. On 15 August 2018, the Prime Minister Narendra Modi addressed the nation from the Red Fort on 72nd Independence Day. In his speech, Prime Minister formally announced ISRO's future plans, which included further Chandrayaan missions to study the moon in detail, first Indian human spaceflight program called as Gaganyaan, and many other space missions. Chandrayaan-2. Chandrayaan-2 is the second lunar exploration mission developed by the ISRO after Chandrayaan-1. It consists of a lunar orbiter, a lander, and the Gaganyaan rover, all of which were developed in India. The main scientific objective is to map and study the variations in lunar surface composition as well as the location and abundance of lunar water. The spacecraft was launched on 22 July 2019 by a GSLV Mk3M1 rocket. The craft reached the Moon's orbit on 20 August 2019 and began orbital positioning maneuvers for the landing of the Vikram lander. The lander and the rover were scheduled to land on the near side of the Moon, in the South Polar region at a latitude of about 70 degrees south on 6 September 2019. However, the lander crashed when it deviated from its intended trajectory while attempting to land on 6 September 2019. According to a failure analysis report submitted to ISRO, the crash was caused by a software glitch. While the orbiter continues to provide valuable scientific data, paving the way for future missions and deepening our understanding of the Moon. Chandrayaan-3. Chandrayaan-3 is the third and most recent lunar Indian space research exploration mission under the Chandrayaan program of ISRO. It consists of a lander named Vikram and a rover named Pragyan similar to Chandrayaan-2, but does not have an orbiter. Its propulsion module behaves like a communication relay satellite. The propulsion module carries the lander and rover configuration until the spacecraft is in a 100 km lunar orbit. Chandrayaan-2's orbiter, which initially had a mission life of 1 year, is now operational for 7 years as it's still functioning with full capabilities. The lander and rover from Chandrayaan-3 will be connecting with orbiter to communicate with Earth. The launch of Chandrayaan-3 took place on 14 July 2023 using LVM-3 rocket, and lunar injection of 100 km circular polar orbit was completed successfully as part of Phase 1. The lander and rover are expected to land near the lunar South Pole region on 23 August 2023. The Chandrayaan-3 mission is a stepping stone towards ISRO's future interplanetary missions. The key idea is technology demonstration of crucial capability to soft land on lunar surface safely that the earlier mission could not achieve. ISRO's cost-effective launches and satellite deployment. ISRO's cost-effective launches have gained worldwide recognition. With their innovative approach, they have successfully placed multiple satellites into orbit in a single launch, creating a global benchmark for efficiency. The Small Satellite Launch Vehicle (SSLV) is a small-lift launch vehicle developed by ISRO with payload capacity to deliver 500 kg (1,100 pounds) to low Earth orbit, 500 km (310 mi) or 300 kg (660 pounds) to sun-synchronous orbit, 500 km (310 mi) for launching small satellites, with the capability to support multiple orbital drop-offs. SSLV is made keeping low cost, low turnaround time in mind with launch-on-demand flexibility under minimal infrastructure requirements. ISRO's future missions. ISRO's future missions promise to push the boundaries of space exploration even further, showcasing its unwavering commitment to technological innovation and scientific discovery. Aditya L1. Aditya L1 is a planned coronagraphy spacecraft to study solar atmosphere, currently being designed and developed by the ISRO and various other Indian research institutes. It will be inserted in a halo orbit around the L1 point between the Earth and the Sun, where it will study the solar atmosphere, solar magnetic storms and its impact on environment around Earth. NISAR. The NASA-ISRO Synthetic Aperture Radar (NISAR) mission is a joint project between NASA and ISRO to co-develop and launch a dual-frequency synthetic aperture radar on an Earth observation satellite. The satellite will be the first radar imaging satellite to use dual frequencies. It will be used for remote sensing, to observe and understand natural processes on Earth. With a total cost estimated at $1.5 billion, NISAR is likely to be the world's most expensive Earth imaging satellite. Gaganyaan. Gaganyaan is an Indian crewed orbital spacecraft intended to be the formative spacecraft of the Indian human spaceflight program. The spacecraft is being designed to carry 3 people, and a planned upgraded version will be equipped with rendezvous and docking capabilities. In its maiden crewed mission, the ISRO's largely autonomous 5.3 metric ton capsule will orbit the Earth at 400 km altitude for up to 7 days. If successful, India would become the 4th country in the world, after the USA, Soviet Union and China, to independently send humans in space. Mangalyaan 2. Mars Orbiter Mission 2, MOM-2, also known as Mangalyaan 2, is a proposed second interplanetary mission by the ISRO. In February 2021, ISRO's chairman clarified that the mission will consist of only an orbiter. The orbiter will use aerobraking to lower its initial apoapsis and enter into an orbit more suitable for observations. PADEX. SpaceX or Space Docking Experiment is a twin spacecraft mission being developed by ISRO to mature technologies related to orbital rendezvous, docking, formation flying, with scope of applications in human spaceflight, in-space satellite servicing and other proximity operations. Chandrayaan. Chandrayaan is a planned orbiter to Venus by the Indian Space Research Organisation, ISRO, to study the surface and atmosphere of Venus. XPOSAT. The X-ray polarimeter satellite, XPOSAT, is a ISRO-planned space observatory to study polarization of cosmic X-rays. The telescope is being developed by the Indian Space Research Organisation, ISRO, and the Raman Research Institute. Chandrayaan 4. The Lunar Polar Exploration Mission, UPEX, also known as Chandrayaan 4, is a planned robotic lunar mission concept by Indian Space Research Organisation, ISRO, and Japan Aerospace Exploration Agency, JAXA, that would send a lunar rover and lander to explore the South Pole region of the Moon. JAXA is likely to provide the under-development H-3 launch vehicle and the rover, while ISRO would be responsible for the lander. ISRO Space Station. The ISRO Space Station, ISS, is a planned space station to be constructed by India and operated by Indian Space Research Organisation. The space station would weigh 20 tons and maintain an orbit of approximately 400 kilometers above the Earth, where astronauts could stay for 15 to 20 days. ISRO's collaborations. ISRO's achievements have not gone unnoticed globally. It has collaborated with international space agencies, including NASA, ESA, Roscosmos and JAXA, fostering cooperation and furthering scientific advancements. St. Mary Magdalene Church to VSSC Space Museum. Vikram Sarabhai Space Center, VSSC, Space Museum, Thiruvananthapuram is in a majestic church building which was St. Mary Magdalene Church till the 1960s. This place is considered as the birthplace of Indian space program. It was in this church that the first rocket systems were assembled and integrated. It has multifaceted roles in the beginning of ISRO by acting as the first lab and as the main office for scientists in the early days. The Bishop House, forming part of the church, functioned at that time as the office of the director, Thumba Equatorial Rocket Launching Station, TERLS. Missions accomplished by ISRO. ISRO has successfully accomplished 124 spacecraft missions including 3 nanosatellites and 1 microsatellite, 93 launch missions including Scramjet-TD, RLV-TD and Crew Escape System, 15 student satellites, 2 re-entry missions, 431 foreign satellites of 34 countries and 3 satellites realized by Indian private players. ISRO's Excellence Team. ISRO's workforce is a testament to its excellence. The Mars Orbiter mission team comprised mostly of young scientists and women scientists, reflecting ISRO's commitment to nurturing talent and women empowerment. It is one of the 6 government space agencies in the world which possess full launch capabilities, deploy cryogenic engines, launch extraterrestrial missions and operates a large fleet of artificial satellites. A big salute to all the great scientists of ISRO who has worked day and night on Chandrayaan missions, Mangalyaan mission and numerous other missions which made each and every Indian proud. A heartfelt thanks to the brilliant scientists, engineers, and the entire ISRO team for their unwavering dedication and remarkable contributions. Your commitment to pushing the boundaries of space exploration fills us with pride and wonder. You inspire us all to dream bigger and reach for the stars. Thank you for making us proud. As we conclude our exploration of ISRO's fascinating facts, we are filled with anticipation and inspiration for the future as ISRO has ambitious projects in the pipeline. Join us as we celebrate the incredible journey of ISRO and its unwavering pursuit of scientific excellence. From awe-inspiring missions to remarkable technological advancements, ISRO continues to inspire the world, proving that the sky is not the limit, it's just the beginning. Thank you ISRO for making us proud.